Man, I'm really upset right now. Somebody broke into my house and stole my limbo stick. Seriously, how low can you go? Alright, just kidding. Sorry about the dad joke. But anyway, what's going on, Algebra Bros? In this video, what I'd like to do is discuss a procedure that you can undertake to uh, analyze the graph of a rational function. So here we go. The first and probably most important step is to see whether or not you can factor the two polynomials involved in the rational function. And if you're able to factor them, you want to go ahead and do it. What you can do from there on afterward is find the domain, which I sometimes leave that for a later step. But regardless, the first thing that you want to do is attempt to factor both the top and bottom polynomials. So generically speaking, you want to see if you can write your rational function in the following format, where the top is factored and the bottom is factored. And one major reason as to why you would want to see if you can factor the top and bottom is to see if your rational function simplifies. So let's say that we factor the top and bottom, and one of the factors, again generically speaking, is ax plus b, and one of the factors in the bottom is also ax plus b. Then clearly those factors would divide out and the rational function reduces. But in terms of the graph of this rational function, what's going to happen is these two common factors that divide out will produce a hole. So this is an indication that there's going to be some sort of hole in the graph of the rational function, which a hole is something that we plot as an open circle. So if the rational function simplifies such as this, then there will be a hole. Okay? Usually what we'd have to do to figure out the hole is figure out what x value would turn each of these common factors equal to 0, and then once we figure out that x value, we plug it into the rational function, and that would give us the y coordinate of the hole. So just to give you a little schematic here, a hole is something that we would plot as an open circle, and typically what happens is you see one part of the graph just kind of leading its way up to the hole and just kind of skipping over it and then finishing up from there on out. And unfortunately, the graphing calculator will not plot a hole as an open circle, so this is usually something that you have to infer using some by hand methods. So that's the second step that we would take when analyzing the graph of a rational function in order to graph it. The next thing that you would do is see if the graph of your rational function has any vertical asymptotes. And to figure out these vertical asymptotes, what we do is we take the denominator of the rational function and we set it equal to 0 in order to solve for x. And remember, vertical asymptotes are plotted as vertical dashed lines crossing the x-axis wherever division by 0 occurs. For horizontal or oblique asymptotes, which would be the next thing that you'd want to look for, what we have to do is compare degrees. And when you compare degrees, you land in one of three situations, or one of three cases. And case 1 would be where your horizontal asymptote is y equals 0, which is the equation of the x-axis. Another case, or case 2, would be y equals a sub n over b sub m, where that's the ratio of leading coefficients. And then case 3 is the situation where there's no horizontal asymptote, which implies that there's going to be an oblique asymptote. And so horizontal asymptotes are lines that are dashed that go horizontally in our graph. And an oblique asymptote could be sort of a slanted line or even a curve. But just to give you a little schematic of an oblique asymptote, you know, maybe it's something like this, a dashed line with a positive slope. But either way, these would be the things that you go after next once you find your vertical asymptotes. We would then want to see what the intercepts of the rational function are, if any. I typically find the x-intercepts first. And in order to find the x-intercepts, the trick is to take the numerator of your rational function and set it equal to 0 to solve for x. And so in terms of a graph, you know, these would, solving for x when you set the numerator equal to 0 would give you any points on the x-axis where the rational function is either crossing or touching. So this is found by setting your numerator equal to 0. For a y-intercept, you use 0 again, but in a different fashion. What you do is you plug 0 into your rational function. So you would plug 0 into your rational function and simplify it down into a single number, and that would give you the y-intercept. So maybe the y-intercept is right here, and that value on the y-axis is found by plugging 0 into your rational function. We get a lot of good information up to this point, but in a lot of cases it's not enough to infer what the different pieces that these rational functions typically have are doing in the graph itself. So one of the last steps is to enlist the help of the graphing calculator, and when you do so, what you do is you go to y1 and you type in your rational function, and generally speaking it might be easier to use the standard form version of the rational function, which is the form before any factoring is done. And if you use that form, then I recommend surrounding the numerator in parentheses when you type it in, closing it off, and then you can hit your divide key to get your fraction bar, which is usually slanted. And then when you type in your denominator, make sure that you use a set of parentheses around that as well. So once you have it typed in, you want to see what this graph looks like in the standard viewing window. So you would press zoom, then option 6. And this set of keystrokes is what I recommend doing for those of you that have a TI-84. For those of us that are using a TI-83, then I recommend pressing zoom option 4. And the reason for that is if you do zoom option 6 with a TI-83, the graph is going to look very jagged, sort of kind of like a cardiograph. And that's basically the results of the graphing calculator trying to connect all the pieces involved, which due to the vertical asymptotes, if you get any pieces, they're going to be disconnected from each other. So the TI-84 sort of resolves that issue, but with a TI-83, if you want to see a better separation between all the different pieces that you could potentially have, then I recommend pressing zoom option 4, and that'll help you identify the different pieces as well as get a better idea of what the vertical asymptotes are and where they're at. Alright, so that concludes the bit on how you analyze the graph of a rational function. I'll be uploading a video or two which illustrates this process in action with specific rational functions. But as always, if you have any questions for me in the meantime, feel free to let me know. Otherwise, thank you very much for watching, and I'll catch you in the next video.